Farmers and ranchers have always adjusted to changing economic and environmental demands. Today's demands are challenging them with a new set of problems stemming from development of neighboring land, oversupply of nutrients, and the loss of farm chemicals. A growing number of farmers and ranchers are adjusting to these problems with the help of an old practice, composting.
We're at the tip of the iceberg right now as to how many different ways we can use compost and really, in general, organic fertilizers, because I believe that there's a need to get away a little bit anyway from the high levels of synthetic fertilizers that we've been using historically.
But composting is not just about problems, it also offers opportunities. Opportunities to lower production costs, add revenue, and rebuild soil productivity.
We have a number of soils in our agricultural systems that have been really depleted. And so by the addition of composts in an appropriate manner, we can start to rebuild those soils.
Because of the problems it solves and the opportunities it creates, composting is a useful tool for sustainable agriculture.
Hello and welcome to our program. I'm your host, Eric Anderson. This program is the third and final video workshop for the Compost Education and Resources for Western Agriculture project, or CERWA. The goal of the CERWA project is to inform agricultural professionals about the role of composting and compost in sustainable agriculture. CERWA is supported by a grant from the USDA Western Region Sustainable Agriculture Research and Education Program, or SARE. The first program in the CERWA series examined the process of composting as a means to improve the handling and value of manure, animal mortalities, crop residues, and other materials generated off the farm. The second program focused on agricultural uses of compost products and their benefits to soil quality, crop production, and the environment. This program takes a broader look. We'll explore some of the emerging issues and trends that are likely to affect the practice and prevalence of composting in agriculture in the next 5 years. In particular, we'll consider the impacts of evolving composting methods, regulations, and markets for compost. Now, in this program, we're looking to the future. But before we gaze ahead, let's set our perspective by briefly revisiting the past and present of agricultural composting. Composting and compost may seem new to farming, but farmers have relied on sustainable practices for centuries to maintain productivity. The next segment features perhaps one of our most famous farm composters, George Washington.
Before synthetic fertilizers came into widespread use, farmers had to feed crops with naturally available fertilizers like manure and fish. Often, using these materials required a decomposition or composting step. One of our most famous composters, George Washington, was not only a general and a statesman, but also a farmer. Washington knew the importance of sustaining farm productivity.
George Washington was a remarkable man in many ways, and most Americans today, unfortunately, don't really know a lot of what George Washington did. They know him as president, they know him as general and founding father, but they don't know him as founding farmer. And he really was. Farming was his main occupation, and it was one of his tremendous interests as well.
Within the pages of George Washington's writings are his thoughts and detailed accounts of many different sustainable practices that he experimented with and implemented on his farms.
Washington experimented with crop rotation systems and settled on a 7-year system that allowed 3 of his fields to rest. On 2 of the resting fields, the manure that went in came from sheep that pastured on those fields. Cloven-hoofed animals with little pointy toes to push the manure down in, and then again the roots and what the remainder of the crop, the hay that the sheep were feeding on, would be there as all of this was plowed under to put value back into the soil.
He tried lots of different fertilizers. In the 1760s, he did a controlled, very scientific experiment with a variety of different fertilizers where he tested them on a variety of different plants to see which ones would work best. So that's a pretty remarkable thing for him to have done. And he took that very inquiring scientific method and he worked with that the rest of his life to try to improve the farms here as best he could.
Washington was an active composter. He instructed his staff on what materials to compost, experimented with mixes, and built a structure dedicated to composting called the Dung Repository.
Because of the location of the dung repository, it's actually very close to the mansion. It's only about 200 yards from Washington's home. It's right across from the stable, which we think was certainly a purposeful decision to get some of the raw materials there. There are two very large gardens that are nearby, and also a fruit garden, basically an orchard that Washington had established at just about the same time that he built the dung repository. So we think it's likely that the compost used there would have been used in those gardens and in the orchard.
Washington worked hard to be a great leader. His desire to lead extended to farming as well.
He wanted to make his farms as efficient as possible, of course, but he also wanted Mount Vernon to serve as a model for American farmers in general. Because he was a wealthy individual, he had the resources to experiment. And he did a lot of things here that he hoped would succeed and that then other farmers in America would emulate.
With the development of synthetic fertilizers and mechanization, organic inputs like compost became unnecessary. However, with growing concerns about the environment and sustainability, composting was rediscovered by agriculture in the 1990s. Now more farmers are embracing composting and compost for a variety of reasons.
Our main reason for going to compost was to move away from manure. We were on a heavy manure program on all our ranches, and for food safety concerns, we decided it would be better to go to compost than manure. We've instituted a HACCP program through our salad plant, which extends back to our growing, and that includes not having raw manure near or on the crops. It includes using the certified compost in place of the manure.
Composting offers farms a tool to convert manure, crop residues, and other materials generated off the farm into value-added soil amendment that can be sold or put to better use on the farm.
We feel that composting and farming make a good mix because we're actually able to use the free organic materials on our farm, get paid by a garbage company to receive the yard trimmings and get revenue there, mix those two things together, and then use it to save money in our cropping operation by buying less fertilizer.
Compost is a resource that benefits soil quality, crop production, and the environment.
Well, I think the compost, well-made compost, is enormously valuable for protecting the health of the soil, and especially the physical properties and the biological community in the soil, because it's basically very close to real humus, which the soil works so hard to produce and we work so hard to protect. And it's the best of all possible ways to recycle organic nutrients and material and put it back in the soil in a form that can do the soil the most good.
Although the percentage of farms in the U.S. that use compost remains fairly small, composting has again become an established agricultural practice, and the trend is expected to continue in the future. The trends and developments in the agriculture and composting industries would tend to indicate more use of compost in the future as well. However, there are a few issues that may hold it back. In this segment, we look at some of the trends that will likely affect developments in agricultural composting in the future. Joining me is David Granitstein, Extension Specialist with the Washington State University Center for Sustaining Agriculture and Natural Resources. Welcome, David.
Thank you, Eric.
David, when you look at the trends that will impact composting in the future, what are the key areas that you see?
There's 4 areas I can think of. One would be the science of composting. Second would be regulatory issues. Third might be economics, and a fourth is environmental issues.
Okay. Well, let's start by looking at the science of composting. What are the key developments that may occur?
As we've seen more and more use of compost and composting in agriculture, we've seen a lot more research begin to try to answer certain questions and solve some problems. This has been particularly true in trying to look at compost quality and dealing with problems such as odor and helping to understand the role of compost in disease suppression. And I think we'll see more of that in the future. It would be very useful to have some real applied work on the economic benefits of composting specific crops, because we need to open those agricultural markets up. But I don't think we'll see great changes in the basics of composting. We pretty well know what those are.
Okay. You talked about the need for research and economic issues. What is the outlook for economics in the compost industry?
Well, compost is proving itself as a cost-effective tool in agriculture. A good example is the use of composting to deal with animal mortalities on livestock farms. Also, compost represents a real potential solution for some of the manure management problems in agriculture. We saw in our second video that a number of growers have experienced significant improvements in crop yield and quality from compost use, and those kinds of experiences will help expand compost in the future. The rapid growth of organic farming is also opening in a market. As those growers look at organics to try to improve their profitability, compost becomes a cost-effective input for fertility and an important part of their soil building program. On the negative side, composting takes more time, so if an operator is going to get into it, they have to know that on their operation it will pay for itself. With the low prices in agriculture right now, compost can look to be a fairly expensive input, and it might be one of the first to go in hard times. And we are seeing competing technologies such as anaerobic digestion come along that may well be more cost-effective than composting in certain situations.
Now, you mentioned organic farming, and there certainly is a lot of interest in that area. What are some other environmental issues that may affect composting?
There's a lot more interest in soil quality throughout agriculture. I think compost can play a real positive role in that. It could be as simple as helping to bring back productivity on degraded soils, or it could play a role in tying up carbon in the soil to deal with some of the greenhouse gas issues. Whatever we do in the soil will probably influence water, and water quality is a very big environmental issue that compost can have a beneficial impact on. Potentially we can conserve water through management of our soils with compost, and in our western region this could be very important. Composting can also help reduce pathogens from materials like manure, and that's a positive.
Okay. Now, regulations was the final area that you mentioned. What's the outlook in terms of the regulatory arena?
I think across the country we're seeing an effort to divert organic waste from landfills to beneficial use, and very often composting is used to process those materials. So we'll have an increasing supply of organic materials probably that are composted. We then need to develop the market side. Composting is being looked at by regulators as a potential part of the nutrient management programs being put in place for many livestock operations. And as there's increased regulation of pesticides, compost could play a role in replacing certain things such as methyl bromide, which is a fumigant being phased out. On the downside, regulators are also looking at requirements for siting compost facilities and for compost quality standards, and stringent standards in either of those could inhibit compost development.
Okay. So we've covered science, economics, environmental and regulatory issues. A lot of issues that could impact the future. What's your assessment in general of the future for agricultural composting?
Overall, I see many more positive trends than negative, so I think we'll see an expansion of composting and compost use in agriculture. However, I think it's crucial to not look at either of those as a cure-all for all the problems in agriculture, but it's important to match either of those to the situation where they have the most chance of doing well.
Great. Well, thank you, David. As you can see, there are many issues that will likely affect the future of agricultural composting, and we don't have the time here to look at each of them in depth. However, we think that there are three issues that are particularly important, and those are composting systems, regulations, and compost markets. So for the remainder of our program, we're going to focus on those three areas. We begin with an examination of the changes that are occurring in composting systems. A composting system is the combination of methods, equipment, and management practices used to convert raw feedstocks into compost. Composting systems range from simple to complex. Simple systems include freestanding piles that are manipulated infrequently and produce compost slowly, perhaps in a year's time. An example at the other end of the spectrum is a mechanized, highly controlled vessel that can yield a product in as little as 3 days. Determining which system will best fit a producer's needs involves consideration of several factors, including available space, volume of material, type of material, markets and uses for compost, local climate, required odor control, and financial constraints. Most farm-based composting systems are variations of the basic windrow composting method, such as the one used by Washington State University.
We build our windrows according to our waste stream, and we essentially mix the dry with the wet and form our windrows, and then those windrows are turned immediately as soon as we get the windrow turned, and it homogenizes, mixes, blends, and adds some oxygen to that first initial stage. These windrows are 12 feet wide, 5 feet high, and approximately 200 feet long. And we turn these windrows on a periodic basis based on temperature. And in the first week they'll be turned about twice, and the second week down to once, and then they'll stay in this windrow configuration for about 10 weeks before they go into a curing or land application.
A growing number of farms are turning to simple forced aeration systems.
The key to the aerated static pile method of composting is its simplicity. In this system we have a simple blower here, simple drainage pipe. It's perforated, allows the air to come out beneath the pile. All of this is operated off of a timer. It's a cycle timer that allows the aeration to turn on and off at desired intervals during an hour's time. We build the material on top of the pipe network, and we're able to control the temperature and moisture content of the final product.
Although these types of systems suit the needs of most farms, composters and equipment manufacturers continue to work towards making composting cheaper, easier, faster, and more self-contained. Developments are occurring at all levels of technology. For example, work taking place in Canada is striving to make simple passive aeration systems perform better.
That we first put a base with an insulating material so the heat would be retained in the composting biomass. So maybe at about 2 inches of peat or sawdust or shavings, whatever insulating material you want to use. And then we put the pipes on with open ends, and they got 2 holes facing upwards, something like we use for the drainage in the septic fields. And then we put them about 3 feet or 1 meter apart, and the holes are about 1/4 inch in diameter. Pipes are 4 inches in diameter, and we can make as long a windrow as we want. We don't want the windrow to be too high because the pressure of the weight of the material is going to compress the material and reduce the airflow. So about 4 feet, 5 feet would be a good height to go by. And then as the pile heats up, the hot air is rising and the cold air comes in at the open ends of the pipes and comes up through the perforated holes and keeps the temperature up. Talking to some of the producers, they found these plastic pipes to be a nuisance. They tend to break. So we had some concrete custom-made slats made with holes in it at the experimental farm in Ottawa, and there they worked well, so that it's a permanent installation. You can drive your bobcat or heavy machinery on it, and the air is coming at the ends and coming up through the slots.
On the other end of the technology spectrum, new systems continue to be developed that rely on more sophisticated technology. These systems provide composters with more control, thus speeding up the process, reducing space, or reducing the risk of odors. Utah State University is working on a drum composter that illustrates one such system.
The drum compost process has some advantages because the thing is completely enclosed and you can maintain temperature year-round. It really doesn't have much effect. The outside temperature really doesn't have much effect on the composter itself. Also, we don't have any cold spots. It's insulated, and so once we get it up to temperature, we're able to kill all the pathogens, leaving only the thermophilic bacteria. It contains odors, and probably the final and maybe the best thing is it's quite a bit quicker.
The primary innovations of the previous two systems focus on the composting process, allowing the microorganisms to work more efficiently. Others are attempting to improve systems by changing the mechanics or containment methods, making composting easier for the operators or more isolated from the surroundings.
The reason that we chose the aerated channel system for this particular farm was had a lot to do with environmental regulations, environmental concerns in the future. When we look at other types of systems, we need much more space. If it's all outdoors, here we get at least 3 to 4 feet of rain between October and March, and which translates to about 3 million gallons of leachate on a 1.5 acre asphalt pad, all of which cost a lot of money to deal with. This particular structure is 70 feet by 120 feet and does the same amount of material that would take 1.5 acres in a windrow composting setting. Also, with possible concerns in the future regarding ammonia emission, greenhouse gases, we felt that if we optimize the use of indoor space, we can actually build systems to control that in the future. So with this facility, if needed be in the future, we could have exhaust control systems on here as well.
Composting systems will continue to evolve and will likely improve the efficiency, economics, and environmental compliance of composting. Although new high-tech systems will be developed, advances will also lead to better variations of simple, low-cost, low-maintenance methods for on-farm composting.
Regulations have a major impact on environmental practices. They can either encourage or hinder a particular practice. For instance, in the past decade, interest in composting has been sparked by mandates for recycling, tightened federal landfill requirements, and state-imposed bans on disposal of yard trimmings in landfills. On the other hand, some states and local communities have adopted policies that restrict how and where composting can take place and what can be composted. When coupled with even a few voices of public opposition, these restrictions can be devastating to a composting operation. The following case study from Hawaii illustrates both the positive and negative influences local regulations can have on a composting facility.
Aloha, I'm Jim Hollier with the University of Hawaii. We're here today in the beautiful agricultural area of Waimanalo on the island of Oahu. Oahu is just one of 5 major Hawaiian islands. As part of this series on organics recycling and regulations, we'll be looking at a local company, Unison Biowaste Conversion. Unison started in 1985 with a mission to recycle dairy manure and wastewater from a local dairy. Unison, however, started bringing in other feedstocks over time, including 35 tons per day of local restaurant residues. The promise of Unison was tremendous. 30 jobs created, 1,200 tons per year of restaurant residuals recycled, and 3,500 tons of a locally produced compost. All the ingredients of success, right? Well, unfortunately not. Unison Biowaste Conversion is no longer in business. We'll be talking to a former manager, Matt Leum, today to see a little bit more about Unison, how it worked, and what were some of the difficulties.
We had a fleet of 7 collection vehicles that went out to businesses on Oahu that generated food waste. We picked it up 7 days a week, the plant, unloaded it into a grinding process, mixed it up and fed it into anaerobic digesters. The digesters produced methane gas. The gas we fed to a natural gas generator set and produced power for the facility. The liquid residue we screened. The solids were then mixed with yard trimmings and composted. The liquid was either added back to the compost as irrigation water or sent to farmers.
At first, Unison benefited from regulations. Food recycling was stimulated in Honolulu by local waste diversion ordinances and a ban on landfill disposal of commercial food residuals. Unison was able to take tons of material that no one wanted and turn it into useful products which helped the community in many ways.
I think Unison had
had a very significant value. For Waimanalo, it obviously had a value to the farmers that utilize a lot of the byproducts that they produced as a result of their operations. And I think to the broader community, not only island-wide but statewide, it was a great example, a great effort to deal with a very problematic concern of the community in terms of the disposal of solid waste and food waste in particular.
One of the products Unison produced was a compost called Hawaiian Green, which many farmers were very pleased with.
It helped our soil. For example, we just had some big rains, and we were able to go in 2 days after the rain, and the soil was still wet, and we were able to plow and still make the ground workable. Whereas before we used the Unison product, one, we wouldn't have even been able to go in and plow. And the reason why is we get big balls of dirt. So it's kind of broken down the clay makeup of the soil to where it's much more workable.
After almost 10 years of relative success, things began to turn sour for Unison. Neighbors began to complain about odors. The regulatory agencies turned over their welcome mat and imposed a series of new regulations that eventually crippled Unison. In April 1999, Unison finally shut down its operations.
Well, in 1995, the third owner of Unison initiated some equipment changes and opened up some tanks. The odors from that, in addition to adding open-air windrow composting, created odor complaints. The State Department of Health then added more conditions to our permit process, which incurred some costs and some time. The city and county also added a new permit, the conditional use permit, to our requirements. And finally, the neighbor did start a lawsuit, which that, with the media attention, created more effort and resource use by our facility.
Back in 1985, when Unison began its operations, the regulatory climate was much different.
At the time, the state required an environmental assessment and a solid waste permit. Both those requirements were met. And over time, the 5-year solid waste renewal uncovered new requirements, including a city permit for composting that was only enacted in 1994. That permit in turn triggered an environmental impact statement. On top of that, the state required a water reuse plan for use of the irrigation water.
Trying to deal with regulatory changes was only part of the problem. Unison's image had been damaged. Unison brought in Herb Lee as a community involvement specialist to mend fences.
I think there probably could have had the community process could have been more proactive and probably could have started much earlier. By the time we really got our feet into this process, there were already lawsuits that were filed, and so that created barriers in and of themselves because now there were attorneys involved and matters that one could not talk to one. The plaintiff could not talk to the defendants and things like that. And so everybody was represented by counsel. And so that kind of, put a sort of a barrier, for lack of a better word, to communication. But there were still a lot of other people that were not involved in the lawsuit that still wanted to talk. And so we chose to pursue that.
Unison was a unique facility with many good ideas and a desire to take on tough environmental problems. But it came at too high a price.
I think one other thing is when you're developing a new technology or a new facility, it depends how much new ground you're trying to cover. The more new ground you want to develop, the more money it's going to take. And we try to accomplish the whole renewable energy thing, anaerobic, food waste recycling, and composting. A lot of it was uncharted territory, and problems come up and plans change, and you just need to have the resources to continue and finish it up.
In summary, the problems that led to the closure of Unison were evolving technology and the inability to raise more funds for that technology, an evolving permitting process, and community relations. While we're sure that these problems are not unique to Hawaii, We hope you've learned something from our experiences. Thank you for joining us, and aloha.
Regulations affecting composting continue to evolve. Many local and state governments are struggling with rules that protect neighbors from potential nuisances without making it difficult and expensive to recycle organic materials. California is among the states that have established regulations and policies for composting, both to encourage the practice and to avoid problems.
Well, the Waste Board has a dual function, both to permit various facilities that deal with things like municipal solid waste at landfills and then composting facilities. So that's the regulatory side. And then we have more of a facilitation side on market development, trying to get materials into the marketplace where people will use them. And we are working pretty closely with the permitting division at the Waste Board on potential amendments to the composting regs that are in existence right now, on providing training to what we call local enforcement agents, who are kind of the inspectors of various facilities, and training to operators on better management practices at composting facilities.
Presently, there is little uniformity in the regulations among states and localities. Regulations range from well-defined procedures and provisions, as in California, to no composting rules at all that can lead to either lenient or strict rulings by the public official left to make the decisions.
Well, local policies can have both a positive and negative impact on composting. You know, every local jurisdiction or entity has its own ordinances and zoning regarding agriculture in general and what can be done on agricultural lands, and then regarding composting and where it can occur, what kinds of situations. So, you know, we don't see those as negative in general. There are some that may be too restrictive, but it's a local decision. And I think it's more important to be trying to educate, you know, local decision makers about how to properly manage compost, how to do it right, and how to use the product, where to site facilities, what are some of the best management practices related to controlling odor and other issues. So a lot of it is educational, and that's really the tack that we've been trying to take, is to work with the enforcement agents and the local jurisdictions and the operators to say, you know, we're not interested in having the bad operators keep operating. We want to make the industry a vibrant industry that's compliant with all the regulations, whether it's local or state regulations, and that's using the best management practices, and then, you know, go from there.
In the U.S. and Canada, most regulations are concerned with composting and compost generally. With on-farm composting, the situation becomes more clouded. Farms usually face a different set of regulatory conditions. Because farms are ideal locations for composting, and farms often practice composting to improve environmental performance, many states and provinces have separate provisions for composting on farms.
Farmers in British Columbia are treated differently under the Waste Management Act. Farming is seen to be almost a motherhood issue, and the decision by the regulators was not to put in too many barriers, to try and make it as simple as possible for farmers to meet the environmental rules. And so the rules are fairly simple. They still require that they can't pollute, but they don't spell out a lot of detail. Farmers are one of the few industries that have that sort of an exemption or treatment. All other industries have to get permits and go through the approval process.
In some cases, farmers may be allowed to compost specific materials, such as yard trimmings, after notifying the state. No official permitting procedure is involved.
If an agricultural operation does bring in some green material from off-site, some of the urban-derived materials, and then composts it and then sells that out in some kind of marketplace, then they do fall under our regulations to a certain extent. Usually they would be in what we call this notification tier, which is not a permit tier. They have to notify the local enforcement agent that they are doing this operation and taking in these feedstocks, and they're subject to various state requirements like vector control and not being allowed to store something for too long. So it's a fairly benign kind of regulatory approach to ag.
Generally, farm exemptions have stimulated beneficial use of organic materials generated on and off the farm. For example, because of flexible farm composting guidelines in Massachusetts, over 100 farms are registered to practice composting of specific off-farm materials. But farm exemptions have also generated some confusion and controversy.
Because a farm will adopt a composting operation and they will produce enough compost from that activity that they have more than they need for their own farming areas, they naturally will want to try to sell it and help to defray some of the expenses of that operation. And to the extent that they're selling that, that somehow in some jurisdictions changes the complexion of the operation. And it changes it from an agricultural operation to, in some people's minds, a manufacturing operation. And I don't think of it that way. I have a hard time making a distinction between selling wheat straw off of the farm from selling extra compost off of the farm. You're still selling a commodity of something that you husbanded and took care of and produced from that farming activity.
The other side of public regulations and policies are those that indirectly stimulate composting and compost use by their effect on related practices and environmental issues. Interest and concern about non-point source pollution, bio-based technologies, and global climate change are just a few examples.
We've gotten to the point that we have saturated our soils with phosphorus, so we have excess phosphorus coming from poultry litter, and with Maryland's nutrient management law that went into effect last year requiring mandatory nutrient management plans on the farm, we have a situation where a lot of farmland is going to be restricted as far as addition of, let's say, additional phosphorus over the production cycle. And so the growers now have all this poultry litter compost that they can't put it on their own land, so what are they going to do with it? So I think composting fits in very well from a sustainable standpoint in composting this poultry litter and then moving it to other sites either here on the Eastern Shore or across the Chesapeake Bay to what we call the Western Shore. So in a sense, we're composting an organic product and then doing some nutrient transfer to other areas of the state that have a deficiency both in organic matter and also in phosphorus and some nutrients.
The USDA has a program called EQIP, and it stands for Environmental Quality Incentives Program. And farmers can take advantage of this program by having a conservation plan for their farm that includes a series of practices. And one of those practices is fertility management. And in that practice called fertility management, they could utilize compost as a form of their nutrients and actually be able to benefit from this EQIP program. And they could benefit through a cost share, so they could get some cost assistance for applying compost.
There was a new executive order passed by the President which was encouraging DOE, Department of Energy, U.S. Department of Agriculture, EPA to work on increasing bio-based products and bioenergy. What this translates to the farmer is an encouragement to grow certain products that will then become another product that will be eventually biodegradable. Now, we wouldn't want this biodegradable product going into the landfills. We'd want to turn it around and compost it as well and complete the cycle.
Regulations will continue to have a huge impact on composting and compost use on and off the farm. It appears that composting and the use of compost will be stimulated as regulations change in response to environmental and economic pressures. However, this will likely require well-managed composting facilities that pay close attention to product quality, environmental impacts, and neighbor relations. In the meantime, compost producers hope for a more uniform approach to composting regulations.
The impact of regulations, again, everybody wants to be safe, but nobody likes undue and over-regulated conditions. And I think each local community has a different perception of the rules that are set by the state. And therefore makes it very difficult to get the proper licensing and the proper permits to expand composting. So if compost is to be taken off, we need to have the enforcement people become one, because you have these different entities and they're all on different pages, and it makes it very difficult to expand composting operations.
Another major influence on the future of composting is the market for compost products. Agricultural users and producers of compost are expected to play a large role in the types and quantities of compost products marketed. The composting industry is currently at a point of transition, changing from a waste-driven to a market-driven industry. There is no doubt that the need to recycle organic materials will remain an important function of composting. However, the emphasis is shifting to the products rather than the process of composting. Let's look at some of the trends in the uses and markets for compost.
In the past, the composting industry, because of the legislation, has been driven from a waste perspective. The term waste has been used a lot. And as we go forward, people are looking at it more as a manufacturing process to create a specific product for specific use to obtain a specific result.
The development of compost products is affected by both urban and agricultural users, creating a demand for diverse compost products and for services associated with delivering those products to customers. This is creating distinctions in price, quality, and source materials or feedstocks.
The way we try to market our compost is to differentiate them, and it's to create a brand name and product characteristics that are unique and use specific, rather than making one general purpose compost. Really, we've gotten away from that concept, and we're more inclined to target our markets by compost use, and that may dictate the feedstocks. It may dictate the screen size of the finished compost, and we sell into several different markets, and each market has their own characteristics that they like to see.
With more growers using compost, there's an increased demand for products that meet fine-tuned production requirements. Therefore, compost producers are developing customized products for specific uses.
Yeah, I think there's lots of new products. We don't try to think them as new products. We try to think of them as prescription blended products based upon analytical data, soil testing, and tissue testing. We then custom formulate compost for each block of field or each field that we work with. So if a field needs extra calcium, or whether it's gypsum or limestone, or extra sulfur or extra potassium, we'll add that to the compost so that the materials that we're adding becomes biologically influenced, and then when we put it in the soil, it becomes much more available to the plant.
Some of the work that I started before I retired was with the blending of compost, where we blend chicken manure compost with yard debris compost, or biosolids compost with garbage compost, or with feedstocks of garbage, where we are getting a beneficial effect, which we believe is a combined effect of the different types of compost, which is a physical as well as a chemical improvement of what is available from a single compost. For instance, when we blend yard debris compost with biosolids compost or chicken manure compost, we are able to use higher levels of compost in formulating potting mixes, which has resulted in increased production, reduced fertilizer needs, and total dependency on the compost for disease suppression.
The trend towards specialization has also led to compost products that have very special functions in a crop production system, like delivering microorganisms for disease suppression, either as a soil amendment or a foliar spray.
There are a lot of companies and groups out now that are interested in developing delivery systems for biocontrol agents, and composting, and compost in particular, is a reasonable delivery system for those types, because you're not only delivering the biocontrol agent, but you're delivering it in a matrix that is compatible with maybe some propagation, and basically feeding that biocontrol agent as you go along with it.
We have a product called Root Summit, which is a compost tea. We've added additional humic acids, fulvic acids, seaweed, different carbon chains to feed the organisms and provide an environment so when they hit the ground that they're able to expand. And the compost teas for us has been another tool to enhance our operation, and I see other organizations doing the same.
An interesting example of a specialty product is micronized compost, a material with very small particles for use in irrigation systems or compost teas.
We grind it to a 1,000 mesh, 500 to 1,000 mesh, by a special kind of grinder that does not create heat like a rotary grinder would. so we don't destroy it, and then we have a powdered compost, about like talcum powder. Micronized compost is being used a couple of ways. A few of them are putting it in their drip, making it into a solution, and put it through a screen and put it through the drip and just feed micronutrients at a time along the drip lines. Some are mixing it into the vat and sprinkling it on with sprinkler systems for total coverage. Some are using it as a foliar spray and spraying it on the vegetation of a fruit crop.
For most agricultural users, compost that serves as a general soil amendment is normally sufficient. Although product quality is still important, the primary requirement remains affordable cost.
Normally for ag grade, we'll stop once we hit the high end of the temperatures and they start coming down, we stop. We can keep turning it and making a prettier product and so forth, but the farm doesn't care. As long as we've taken it through the cycle and we see these temperatures start to subside, that's when we stop. We don't want to put any more money into that material to make it pretty. That, in our eyes, that's not the case. And I think some studies coming out now are kind of geared that way, that sometimes we have a tendency to overdo things, and so we try to keep it as simple as possible to pass the savings on to the farmer.
Because compost is a new and unknown product for many users, there is confusion among users regarding what compost product they need, what qualities it should have, and how to use it. Therefore, efforts are being made by the composting industry and public agencies to develop standards and specifications for compost products.
Currently, there's no national product quality standards for compost in the marketplace. And although the U.S. Composting Council has worked on this for about 10 years, we recently received a U.S. EPA grant to develop these standards. Some of the potential items that might be covered in product quality standards would include things like pH, soluble salts, organic matter content. The folks in the organic community, I believe, would like to see us disclose ingredients in the product, which we have. The Composting Council has already started a pilot project called the Seal of Quality Assurance, which will allow companies to participate and more or less certify that their product has been tested utilizing the Composting Council's best practices test methods, and they have provided directions for use of that product at the point of sale. So those three criteria, we already have a pilot program started in the kickoff of the Drive for Standards.
The emphasis and growth of markets for compost has also changed the methods of marketing. Compost suppliers are using product promotions, educational forums, and extended services to reach potential users, particularly agricultural users.
Key is education. We have ongoing seminars, we have lots of breakfast meetings, we have meetings where we'll take the growers out in the field and look at the soils and talk about different organic matter systems, and then media, using the media to help that growth, local newspapers, and just educating the farmer that their other neighbors are using this.
For on-farm composters, the potential revenue from selling compost comes at a cost. Marketing requires a dedicated effort, at which point composting becomes an enterprise in itself that can be distracting to the main business of the farm. Increasingly, on-farm producers of compost are collaborating with entrepreneurs to distribute their products.
Typical questions a farmer would want to ask themselves when trying to analyze whether to market their material off-farm or not would be issues of potential revenue they have to expend in a marketing program and revenue that they can return in product sales. And in many cases, on the surface, it seems that the product sales that they can get are based on what a farmer will hear about bag sales or high-end retail sales as a sales price. The thing that we always have to remember is that in order to achieve that high-dollar sale, there's normally an extreme amount of expense that goes into that. So they need to do their homework, and they need to find out what marketing costs for each market niche that they're going to go after will cost them.
We understand that farmers, whether they're dairy farmers or poultry producers or hog farmers, their primary business is raising their animals, and marketing compost requires a lot of work and time. And so therefore in our company we are helping the producers not only produce the material but also with the marketing.
Individual farmers don't produce enough quantity to satisfy a market demand. They can sell compost out front, put a sign out front, and people can come in with pickup trucks and get a load, but that's not marketing. If they want to satisfy the needs of a local nursery or something like that, they probably have to come up with more quantity than an individual farmer can. So they lack that mass that they can sell. And the way they overcome that is to either have a farmer cooperative where a group of farmers can make enough quantity and make enough quality, or to have a contractor who is a centralized salesperson, a broker, who can broker compost from a group of farmers. And then there's enough quantity and there's a single effort of marketing.
So far, we've examined the factors that will affect the future of agricultural composting. But perhaps the larger question is, how will composting influence agriculture? As our opening sequence reminded us, farmers have always adjusted to changing economic and environmental demands. And today, farmers face a number of challenges. They are expected to balance nutrient inputs and outputs, to reduce erosion and runoff, to conserve water, to cut back the use of synthetic chemicals, to minimize odors, to maintain soil productivity and organic matter, and to take advantage of niche markets for farm products. Generally, they're being expected to farm in a more sustainable manner. Composting can advance all of these goals. Therefore, many observers expect composting and compost to play a larger role in meeting the changing demands of agriculture. Let's hear from some of these proponents.
In my opinion, the use of compost in agriculture is probably one of the most untapped opportunities in America today. The traditional farming system, commercial fertilizers, pesticides, and herbicides, has been so successful and used for so long, 40 or 50 years. The negative factors with that program, loss of organic matter, perhaps the detriment of the microbe population, things of that nature, those disadvantages have now become somewhat evident to some farmers. The composted organic materials added as a soil amenity offers an opportunity for every single acre to be improved in its water holding capacity, its nutrient package, its microbe package, its the various things that go to make good soil. It's my opinion every acre of farm ground will benefit by the addition of a relatively small amount of compost. And I think that market is coming at us like a load of turkeys.
We have a number of soils in our agricultural systems that have been really depleted because of continuous cropping over a number of years, and they basically burned out the organic matter. And so by the addition of composts in an appropriate manner, we can start to rebuild those soils.
Here in the Salinas Valley, we have a problem with saltwater intrusion. It's a problem that's been in existence in this valley for over 40 years, maybe 50. And one of the reasons for that is overpumping. And you have the fresh water being pumped too much and the salt water coming in. The aquifers empty into or open up into the ocean so that the salt water is able to come in. So our wells aren't going dry, they're just being replaced by salt water. Composting would really help to keep that moisture in place so that we could have more conservation of the water system. If you don't pump it, that means it's still going to be there and will still last a lot longer. So I think those are big issues in this valley. And that has to do with water quality too. So here you have a consequential effect of composting.
Through the heating process or the composting process itself, really gets rid of plant pathogens. It kills weed seeds, but we're also getting rid of E. coli and Salmonella, which might be a source or a source of problem for the food quality protection. And we're very interested in that people are coming right out. Sometimes they'll even grab some of the broccoli straight out of the field and start eating it. So we're very concerned about the safety of our product, and we believe compost is helping us in our food quality protection.
I've done some work on raising potatoes. And potatoes, Colorado potato beetle is the #1 problem. And we've discovered that if we mound or hill the potatoes with immature compost, that we can control potato beetles. And therefore, this is of great interest to the growers on Prince Edward Island, Canada, which are big producers of potatoes. And they're right now, the entire island is composting all of its garbage as well as its sewage sludge. And the potato growers are looking at this as a possible means of getting some potato beetle control to reduce their dependency on insecticides.
Organic farming is on the increase in the United States. And their sources of nitrogen are not inorganic sources, they're organic sources. Manures is one thing, nitrogen-fixing crops is another way where they can get their nitrogen, but compost is actually a third way of getting nitrogen into their crop. So as more farmers begin to go to organics, they're going to be looking for organic nitrogen sources. And compost is one way of supplying that need.
20 years from now, we're going to have another 1 million people. There's 2 million in this small area now. We'll have 3 million in 20 years' time. I think the public will demand cleaner water than we've got now and cleaner air than we've got now, or at least the same quality. And to achieve that, I think composting will be one of the options where people aren't going to be as happy with handling manures as a liquid form. They're going to be much happier with a compost product which has a lot of benefits as far as odor control, more stable nutrients, less likely to pollute when you're handling it, and also a bigger market where it can go to.
It costs money now to get a truck down, to take the animal away to a renderer, and that cost is getting higher every year, and they're very unreliable because there's fewer and fewer renderers. So that you call a renderer and you got the cow laying out there, and it may be out there for 3 or 4 or 5 days before somebody comes and picks it up. And if a farmer knows what he has to have in terms of materials on hand to compost, and he has that ready for a occasional large animal death, then he can take care of that day, which is a whole lot more sanitary than waiting around for somebody to come pick it up. Swine industry has accepted it very well for mortalities. It works very nicely for swine, almost better than chickens.
It's pretty clear that as the other, 4.8 billion people on the planet become more developed, and they have refrigerators, and they have cars, and so forth and so on, that we're not going to beat the global warming problem as much as we would like to. We're going to have to adapt to a certain amount of climate changes. And that produces another interest for EPA in terms of adaptability. What can we do to make the Earth more adaptable for the changes we expect from climate change? And compost plays a role there in that it can help to make soils better able to absorb heavy rainfall events, or better able to sustain crops in droughts because it'll hold water for a longer time.
One of the reasons we're really wanting to promote composting is not just as a waste management methodology, but also some of the really neat things that are being done with compost right now that also sort of fall into our area. Compost is being customized or tailored to do certain environmental remediation activities, such as bioremediation of contaminated sites that might have been contaminated with petroleum or pesticides. There's military bases that are using compost to remove explosives out of the soil, eat it up. Reforestation, wetland restoration, erosion control, nutrient management. There's just some really neat things that are being done, and that's one of the ways that we're trying to promote composting through, is not just as one way to handle a waste material, but it really is a valuable resource that can solve a lot of problems cost effectively. It's a lot cheaper to remediate a contaminated site with compost than to haul this material off and handle it as a hazardous waste.
Tempering these positive expectations is the fact that compost literally comes at a price, and composting requires time, money, and attention. The cost of composting is a limiting factor.
The interest in composting among farmers, at least here, isn't that great. Manure is still a waste product, and it's still something you get rid of the cheapest way you can. And composting isn't the cheapest way right now, although when the regulations come into full effect, it may be. We see a growing interest in organic farmers, and they are interested in compost, and they are interested in composting. And but that's small relative to the total number of farmers here.
The whole key to a good composting operation is to have the market, because you're taking raw manure that can be spread on farmland here without very much regulation and concern, and you're putting it through a composting operation that's increasing the cost of that manure and yes, increasing the value, but you still don't have a market for it to go to.
Something you hear a lot about is the potential for compost into the ag markets. And I guess I've had mixed feelings about that, and I've had doubts about that. Basically, you're taking feedstocks, in this case poultry litter, which is readily available for nitrogen supplement to farmland. And now you're composting, which dilutes and loses some of the nitrogen. So now you're trying to sell back into the ag market something with a lower nitrogen content. And their initial reaction is one of disbelief and skepticism, and why are you doing this to this perfectly good poultry litter? But in the end, we believe that the compost qualities of natural plant disease suppression, increased water holding capacity of the soil by addition of the organic matter, some natural insecticidal qualities, it leads to a healthier plant. And so what we believe is that the compost actually has better value composted with less nutrients available than the nutrient value of a raw litter. So lately we've been working with a fertilizer company on some chemically amended compost for use on ag crops, and there has been some work done out there that suggests that there will be an economic benefit.
It remains to be seen whether or not composting and compost will live up to the expectations. But at this point in time, it appears that composting will again become a significant agricultural practice that will help fulfill the promise of sustainable production. Perhaps the guarded optimism of composters is best reflected in the sentiments of strawberry producer Tom Jones.
We're beginning to just scratch the surface. Yeah. You know, we've been using and observing compost for 2 years, and what we're seeing certainly is exciting, but you don't go to a 2-year-old and ask for wisdom. We're going to keep using it and keep working with it, and hopefully 20 years from now I can have some words of wisdom for you.
This concludes our program and the Compost Education series. The SERWA project has developed and gathered a lot of useful information about composting and compost use. You can access this information at the SERWA website. On the website, you'll find resource materials designed to complement the 3 programs in the series. For example, you'll find a state-by-state list of government agencies that deal with compost regulations. On the website, you can also access the Compost Connection newsletter developed by Washington State University. There also are links to many other sources of information about composting and its role in agriculture, including the U.S. Compost Council, the Canadian Composting Council, Biocycle Magazine, the Journal of Compost Science and Utilization, and the Composting News newsletter. We'd like to thank everyone who has helped make the SERWA Video Workshop series possible, including USDA Western Regional SARE program, the farmers, ranchers, composters, and other professionals who freely shared their expertise with us, the workshop site facilitators, the SERWA project team, sponsors, and partners. Finally, we thank you for participating in this project. We hope that the information that you have gained will help you advance the goals of sustainable agriculture.